Okay, so let's hit it here. We're solving trigonometric equations, and we got 3 examples, and they're going to take us into quite a lot of learning through them. And in the next session, we'll take it another step further. So kind of see this video in this session as part of another one as well. We're going to, as I say, keep learning. So determine all solutions for sine theta equals negative 0,47 in the interval minus 360 to 360. So let's play a little bit of guess what I'm about to do. What 4 letters am I about to write down on this diagram to help me know which trig ratios are positive where? Well, I'm going to write down CAST. And I say what am I going to do because maybe you're not going to use your cast diagram at all. Maybe for you what you're going to do is to go, well, I'm looking at sine theta, so why do I need a cast diagram? I know what sine theta looks like. There's what it looks like up to 360. And if I went the other direction, of course, I need to go all the way to there. And that's from negative 360 up to 360, 0. And here's some important points, minus 180 and 180. So maybe you don't use the cast diagram. You just got your graph ready to go. Okay. But either way, let's keep both of those there for reference and solve for sine theta. So remember, when we did this before, we kind of found our reference angle by going arc sine, which we just kind of called shift sine, of the positive value over here. So here's what sine is. It's a negative value, but we're going to take our kind of shift sine, and I'm going to stop going like shift sine now and just say shift sine, of that to get our reference angle. So calculator out, there is mine. I was doing something very exciting recently, as you can see. And I'm going to go shift sine of 0,47, and let's go to no decimal places. We just got to the nearest degree. What do you get? Well, 28 comma something or other. So 28 degrees is our reference angle. Done with the calculator, which means that kind of our reference is 28 degrees. But sine is negative, we see. So which 2 quadrants are we working in between 0 and 360 if sine is negative? Well, we're working over here and over here. So if we look at our cast diagram to help us, then we'd say, okay, well, there's the one angle. Well, let's do it in blue, not blue. Let's find a nicer color here. Let's go. Our one option is that we go round here. So if that's 28, then we've got our one option. And what is that option, by the way? Well, that's 180 plus 28. So what do we get? 208. I'm asking, so I'm keeping you up to date. I love that. And I said I should know what 270 times 3 is. Well, okay. Well, I should know. And I'm going to check because I'm terrified I'm going to get this wrong. But it's fine. I can sneakily use the calculator in the background. 208. Okay, cool. So 208 is our one option, which means that's kind of that point over there, give or take. And our other option, if we're just looking in the 4 quadrants, is to go, well, if that's 28, then what's our second value between 0 and 360? Well, we could just go 360 minus 28, right? Which gives us 332. So 332 must be over there. Notice that what we're solving for here is excuse me, what we're solving for is all the values where sine theta is negative 0,47. So they should all be along the same value here, which means we can see that they're going to be another 2 solutions over here. And they are first 2 solutions we've seen. Now, we've got our 2 solutions. Let's actually jot them down here. So we've got theta equals, well, we said the first one was 208 degrees, and we said our second possible solution was or theta equals, and our other one was 332 degrees. And we needed our cast diagram or some sort of idea to get those 2. Now, what's the period of this graph? How often does sine theta repeat itself? Well, almost as much as me, but it repeats itself every 360 degrees. It takes me all week. So it repeats itself every 360 degrees. So this blue point here, if we kind of backtracked another 360 degrees, we'd be over there. In other words, if we had gone backwards, we would have just been at negative 28 degrees. Are you with me? We could either have gone back by 28, look, there's the negative version, or what we could have said there was, let's take 332 and just subtract 360, because the graph repeats itself every 360 degrees. That's happening all behind me, but somewhere in that direction. 332, and we just subtracted, if we just subtracted 360, we'd be at another solution. Now let's look at this pink option here, 208, that was over here. If we subtracted 360 degrees, so if we went up there and we subtracted 360 degrees, we'd be at another solution. So if we took 208 and we subtracted 360 degrees, we could get our second solution, which is, what do we get? Because that would be the same as going all the way around that way. So if we took our 208 and we just subtracted 360, what do you get? Minus 152, me too. Minus 152 degrees. So they're all our solutions within this range, or within this domain. This feels weird to say the range. So between minus 360 and 360. Now let's just say that the question changed and we said let's increase our graph and keep going. There would be another pink solution over here and there. What would the value of this pink solution here be? Well, we've just added another 360 degrees, haven't we? So we take 208 and we just add 360 degrees. What about this next kind of blue solution over here? Well, it's this one here and we've just added another 360. So in general, our two solutions, so we've got all our four solutions, but in general, what we could have said here. So let's just capture this in general. If we just wanted to find all the solutions, our one option was theta equal 208. That we found with our cast diagram. But we could add 360 degrees, right? Or we could add another 360 degrees. Or we could add another 360 degrees. So we could add maybe one of these times 1. Or we could multiply it by 2, because we could add 2 lots of 360 degrees. Or we could add in, 300 of these 360s. We could add, because it keeps repeating itself every 360. Yeah. So we could do that. Or we could have subtracted 360, right? And we would have got another solution. Or we could have subtracted 360 twice. So we could have subtracted 360 times 2. Or times 20. Or times kept on going forever. So I'm going to write this like this to say we could have added 360k times where k is an integer. So just behind me I'm saying that k is an integer, which means that we could have added 360, or if k were negative 1 we could have subtracted 360. If k were negative 2 we could have subtracted 2 of those 360s. And our second option, or theta could have been 332. That was the second option between 0 and 360. And we could have taken that and done the same idea, plus 360k, where k is also an integer. In other words, 332, but we could have added a whole lot of 360s or subtracted a whole lot of 360s. Okay, so let's do 2 more examples. And again, we're just tying these ideas in. So again, we're looking between negative 360 and 360. So I'm definitely going to have my cast diagram here for reference. And I'm not going to draw the graph this time, but in fact, let's draw the graph. Why not? Graphs are fun to draw. So don't you agree graphs are fun to draw? I'm just asking for it. I can just imagine what you've just A, wanted to write and B, actually written. But let's have cos over here. Let's go for a nice, pretty yellow diagram and go, we're just going to do it between minus 360, because that seems to be our domain here, and 360 degrees. 0, and so it's going to hit these axes here. But that's the information we want. What symmetry do you notice about the cos graph? Well, in the positive direction, it looks like it's doing the same thing as the negative. So if we get some sort of value, let's say we get a value over here, and that's 100 degrees, well, it's probably going to relate to an angle here that's negative 100 degrees. If we get an angle that's over here, that's like, where's that, 260 degrees, well, then there's going to be another one here at negative 260, right? Can you see the symmetry going on there? But I don't know where we're going to, so let's get rid of, I knew that would happen, those dots. Come on, go away. They're gone. Yay. If only, if only it were that easy, right? So let's work on our equation here. So we got 5 cos theta minus 1 equals minus 4. What do you need to do to your equation so it looks something nice like cos theta equals? Well, we're just going to rearrange, right? Add 1 to each side, divide by 5. So add 1 gives us minus 3, and therefore we got minus 3 over 5. Now, it's between this, so let's find what our reference angle is to start with. Reference angle, remember we're going to go for our cos, shift cos of 3 over 5 of our positive. Now, I always say do the positive in cos. In the case of cos, maybe you'll start seeing why it doesn't matter for cos if we did the reference angle using 3 over 5 or negative 3 over 5. But we've got 3 over 5 over here. So our reference angle is 53 degrees. We may or may not have seen that 53. Let's see if I can just put it this side of me so it's still captured there. So 53 degrees. Now, cos is negative. So as much as our reference angle is over here at 53 degrees, which two quadrants are we working in? Well, we must be over here and over here. So in other words, our two options, let's do one in, what do we have here? This dark blue. So our one option is over there. So find out the one option and plot where it is on your graph, and then find out what your second option is. Okay, so our one option's 127 degrees, which means that that's about over there, right? That over there is 127 degrees, which would relate to negative 3 over 5. And our other option, let's go, what Pibble's going to work out quite well. Other options down here, and it's going to be all the way over here. And what do you get as your second option? Well, 233 looks like, right? So in other words, there's our second option there at 233 degrees, which will also have a y value of minus 3/5. So our two options for theta are, theta could be 127 degrees, because cos of 127 is minus 3 over 5. Or our second option might be that theta equals 223. Did I say 233, wasn't it? 233. The glories of writing untidily, right? 233. That would be our other option. But now we said by symmetry, if we just went this way, wouldn't this value just be minus 127 degrees? So, or minus 127 degrees. And this option over here, well, again, if we just went symmetrically about it, would be minus 230 degrees or minus 233 degrees. Okay, so it seems like for cos, if we get a solution, another solution will just be negative of that. And we can see that here, because look, cos is positive in the first and the fourth quadrant. So the positive or the negative value is going to be the same, right? Because cos relates to x over r, so the y value doesn't matter. So as I said this whole time during trig, some of these bits of the puzzle will start falling into place and speaking to each other, so you think about it in terms of the graph or the cast diagram or both at the same time a bit. So we've got all our solutions within minus 360 and 360. Look, there they all are. 1, 2, 3, 4. Now let's just look a little bit in general. So in general, it looks like we'll have theta will be 127. Now, we could just keep adding 360, right? Because then we get another solution. And we could subtract 360. So we have this idea again of plus 360k, where k is an awful looking integer, where k is an integer. So if we added 360, we get another solution. If we subtracted 360, we'd have another solution. But k could have, theta could have been positive 127 or negative 127. Look, where we saw another option. And then we could keep adding and subtracting 360s. Or theta could be 233. Again, it could have been the positive or the negative 233. Notice that in maths, plus or minus means it's the positive value or the negative value. And that's why it's very annoying when people go, it's plus minus 5 rand. And you're like, was it positive 5 rand or negative 5 rand? Are you going to pay me or, So anyway, so plus minus in maths here means it's plus 233 or it's minus 233. And this could repeat every 360. Key part is that you're understanding that there were these 4 solutions. The kind of jumping into tomorrow's or the next session is this general idea. Okay, last one. I know it's been kind of a longish video, but as I said at the beginning, we're getting to grips with quite a few things here. So our last bit, tan 2 theta equals minus 2,147. Sorry, just checking that result. Between 0 and 360. Okay, so again, we've got a couple of things here for reference. So I'm going to keep the video going, not hit pause. And our other thing that we've got maybe for reference is a diagram, but this time we're going to have a diagram of tan 2 theta. Now, we did this in the last one a few times of what's the effect of that 2? So tan 2 theta, how is that different to tan theta? Well, everything's going to happen twice as quickly. So our asymptotes now are going to be at 45. And then remember our asymptotes were at 90, at 270, and then we kept on adding 180 to these, right? Remember that was the idea, that we kind of added 180 and said, okay, well, then we had another one at 450, and then we had another one at 630. So this time everything's happening twice as quickly. So 45, which means instead of happening every 180, they're happening every 90 degrees. So now this is 45, everything's kind of halved because that's another 90 there. So if we start at 45 and we add 90 each time, we're going to get to 135, 225, and then 630, that'll happen twice as quickly. So 315, and then we're out of our domain. So we've got 135, 225, and 3115. And otherwise our graph shape is going to be the same. So we're going to do this over there. It's going to do this. It's going to do this. And it's going to do this. And it's going to do, and that's about as far as it's going to go. So this tan 2 theta is a negative value. So between 0 and 360, how many solutions are we going to have? Well, this value of negative 2,147 blah, blah, blah is, let's say it's down here somewhere. 1, 2, 3, 4. Looks like there'll be 4 places where it's going to be negative 2,147. So let's use our same thinking that we used before. And this is going to expand and take our thinking nicely. So let's go for it. Let's make a little bit of space here. And say, okay, let's find our reference angle. So our reference angle is tan, and we're going to take it of the positive value 2,147, and calculator, because if you know what that was, it's a little scary. So 2,147, and we get 65, something, 65 degrees. Let's just go nearest degree for now. So that's our reference angle. Reference angle. 65 degrees. So it means that we've got kind of a reference angle here of 65 degrees. So in terms of using our cast diagram, we would say, okay, well, tan is negative. So we must be working in this quadrant or in this quadrant, right? Second or fourth quadrant. So we go here and go, well, let's reflect that triangle. If that's 65, then what is the value of the angle over there, that outside angle? Well, that outside angle is 115, right? So 115, because we went 180 minus. So 115 looks like it would be one solution. But remember, that would be a solution for 2 theta equals 115, because that's 2 theta over there. So tan of 115 equals minus 2,147, which means theta must be 115 over 2, because you must have divided that by 2. So according to this thinking, theta equals 115 divided by 2, and so we get our answer of 57.5. There's clearly one option, right? So that must be that value there on our graph. And we could do the same thing and go, well, we could go round to this part and say, well, we could go over there and say, well, this value over here, how much have we added to get from 115 to this red angle? Maybe let's rewind a step. What is the value of that red angle? Remember, this is going to be 65. So what's the value of that red angle over there? Okay, so you want to go, well, 360 minus 65 gives you 295. So the question are we asking ourselves? We've gone from 115 to 295. What did you add to get from 115 to 295? Well, we added 180 degrees. Now, if you think of your tan graph, and I know this is a lot we're taking in, but this is good stuff that we're taking in. Think of your original tan graph. There it is there. There's some asymptotes, and it went like this, and it went like this and this. What's the period of y equals tan x? How often does it repeat itself? Well, it repeats itself every 180 degrees. So if you've got a solution of 115, isn't your next solution just going to be 180 degrees later? Okay, so let's put myself back here and make sense of that. As I said, remember, two-part, we're like seeing a whole lot of things here today. And this is exciting. Aren't you excited by it all? No, not really. Okay, well, maybe a little bit. So we've got our one solution of 115, and we know that our next solution must be 180 degrees later, because the graph repeats itself every 180 degrees, which means that if 2 theta was 115, surely our next solution was just 180 degrees away, or 360, or another 180. So it could have been a number of 180s away. So in other words, plus 180k Because if there was an answer, let's say, the next one's 180 away, the next one's 180 away, 180 away. You're going to get answers every 180. Or you could have subtracted 180 and gone backwards to get an answer every 180 degrees. Okay, now just look at your equation here. We divided this by 2, right? Because we wanted theta, not 2 theta. So we divided by 2. So therefore we divide this by 2. Now look at this graph over here. This graph here that we've drawn of y equals tan 2 theta. What is the period of that graph? How often does it repeat itself? Well, it repeats itself every 90 degrees. Look at that. Isn't that matching so beautifully? That every 90 degrees we've got another solution. So 57,5 is one solution. So let's go 57,5, and I'm cheating here and going, there we go. And if we add 180 degrees, there's our next solution, 237. There it must be that one over there. What happens if we add another, not 180 degrees, after all of that, 57,5, okay. And if we added 90 degrees, there's our next solution, 147. That matches a bit better. And then our next solution after that, add another 90 degrees, 237. Okay, add another 90 degrees, 327. Add another 90 degrees, 417. No, clearly we're outside of this. That must have been like over there somewhere. So there are all our solutions. So we've got 57,5. So if we wanted to write them all down, we go 57,5. We would go for, well, 57,5 equals plus 90 equals 147,5 degrees. Then we could add another one, 237,5 degrees. And finally, we could add another one, go 327,5 degrees. Okay, so that was a whole lot, right? And just really getting to grips with our graphs. So practice the few in exercise 6 to practice, and yeah, enjoy kind of determining those and seeing what you get. Yeah, as I said, it's kind of one of those things that we're getting into our trigger a little bit more. So yeah, that's that.